Yeah, hi everyone. Good evening. I think I'm audible to all of you guys. Can you please confirm in the chat if I'm audible? Yeah. Okay, so welcome guys to day 15 of our computer vision for developer series, and today we'll try to learn a very interesting and very important concept in the field of object detection called RCNN and faster RCNN. Okay. Yeah, so maybe first RCNN I'll try to cover tomorrow. Today I'm going to give you the intuition of the RCNN. This was the first architecture, or let's say first algorithm proposed in the object detection. Okay, so we'll try to understand about the RCNN, like how it works and what is the issue with the RCNN. Okay, why people used fast RCNN. And then after fast RCNN, we'll also explore something called faster RCNN. And I think if you see my last session, okay, I was talking about the object detection, introduction to object detection. There I already discussed there are some few algorithms we usually use, right? And RCNN and fast RCNN are deprecated. Okay, so let me write in my board. I think that would be fine. So see, in object detection, object detection, we use some architecture. First of all, we have something called RCNN. Then we have fast RCNN. Fast RCNN. Then we have faster RCNN. Faster RCNN. Okay. Then we have SSD, single shot detector. Then we have YOLO. Okay. So I think I told you. So these two have been deprecated. That means RCNN and fast RCNN have been deprecated. Nobody uses nowadays. So we have to learn from faster RCNN. But if I want to discuss the faster RCNN theory, first of all, you have to know about RCNN, then fast RCNN. Okay. Then you will be able to understand this faster RCNN in a better way. Instead of if I start faster RCNN directly, so you might get confused. Okay. That's why what I thought, let's first of all cover the RCNN and fast RCNN. All this deprecated, but I'm going to show you the theoretical explanation. Okay. Like how this RCNN works for the object detection. Okay. Then why fast RCNN came, then after fast RCNN, why faster RCNN came in the market. Okay, so each and everything we'll try to explore one by one, then your understanding would be more clear. Got it? So there was a like little change in my plan. Initially I thought I'm not going to cover the RCNN and fast RCNN. Okay, but later on I realized that if I'm not covering RCNN and fast RCNN, so there would be an issue in your mind, like how this faster RCNN is working. So that's why we'll cover each and everything. Okay, then once this two is done, we'll try to understand the faster RCNN, and we'll try to implement with the help of practical code. Okay, we'll be using detect on true library. We'll perform the object detection with the help of faster RCNN model. Then we'll also explore SSD and YOLO. This is the entire plan. I hope you got it. So in this session, I'll explain the RCNN. Okay, RCNN part. So if you haven't checked out my previous session, guys, you can check it out. So this is my playlist. This is my playlist, Computer Vision for Developers. So here we have already covered lots of things, and this is the introduction to object detection session. Try to check this session first of all. Okay, if you are completely new to the object detection, and here I discussed the data annotation part, how we can do the data annotation for the object detection. Okay, then you can start this session today, guys. Okay, yeah. So let's try to understand the RCNN. Okay, RCNN in the field of object detection. CNN versus RCNN. See, CNN, this is the convolutional neural network. Okay, this was the base architecture, and now you will be using the base architecture. On top of that, you will be using some more layer, or let's say some more branches. Okay, to perform the object detection. I'll tell you. Okay, how? No coder. So how object detection works? We at the end we use the CNN architecture only. Okay, CNN architecture only. The convolutional layer, the pooling layer, padding layer. Okay, each and everything we use. On top of that, we add another branch there. Okay, to classify the object or object location, that means the bounding box. We'll try to understand this part. And why I took some time, guys, to start this session, because you saw like last session I took, I think 5 days back. Okay, so I took 5 days break because I wanted to prepare some amazing resources for you so that your understanding would be more clear. Okay, so that's why I prepared this entire PPT. So in this PPT, we'll try to understand this RCNN. Okay, RCNN, fast RCNN, and faster RCNN. Each and everything we'll try to understand. That's why I took some time, because I was preparing the content for you. I was preparing the resources for you so that I can explain better way. Okay, yeah. Because see, I want to clarify each and everything. Okay, so that is why I usually take some time to uh, provide my lecture. I can also cover it as a high level, but I'm not going to cover, because at the end you also need to understand, and computer vision is all about visualization in your brain. Okay, so if you can visualize everything in your brain, so you will feel like amazing. Okay, so let's start, guys, but initially I will just ask you one favor, guys, and this would be the request to all of you. So, see, I think there are many people there watching my content, but whenever it comes to subscribe to my channel, so you guys are not doing the subscription. Okay, so please try to do the subscribe. Let's hit 50K subscriber as soon as possible. And definitely, I'm planning lots of content in this channel, guys. After computer vision playlist, I will come up with another new playlist. Okay, and I'll try to cover in depth. Yeah, so please try to support the channel. Let's hit 50K subscriber as soon as possible, and let me know if you need anything else from my side, guys. Okay, yeah, before starting the RCNN, guys, first of all I want to show you the RCNN paper. So this is the RCNN paper, guys. I will attach the link in my description. From there you can check it out. Otherwise, I think I also have a resources GitHub repository. It is also attached in my description. Okay, from there you can open it up. So in the day 15 I'll try to add the paper link. Okay, and there is a Telegram group, guys, I have already created. If you are interested, you can join in the Telegram group for the discussion. So this is the paper. The paper name is Rich Features Hierarchies for Accurate Object Detection and Semantic Segmentation Take Report. Okay, so this paper written by Ross I think, what is the spelling, Girschik, Jeff Donahoe, then Trevor Darrell, and Jitendra Malik. Okay, and you can see this is the entire paper, and the paper proposed by these are the guy. Okay, so they did this research uh, for the first time in the field of object detection, and they proposed this RCNN network. Okay, RCNN network. Now what is the full form of RCNN, guys? What is the full form of RCNN? Let's try to understand. See, RCNN full meaning is region based convolutional neural network. Okay, region based convolutional neural network. Okay, and then it's a convolutional neural network. On top of that, they have created another branch. Okay, yeah. Now I think you know, guys, how image classification works. Yes or no? How image classification works, how we can perform image classification with the help of CNN architecture. So we have already discussed through the entire playlist. Okay, I'm not supposed to again explain how the image classification works and what is the architecture we use. Each and everything I already clarified there. Okay, so you guys are already familiar with image classification. So we'll be using the same architecture. On top of that, we'll be doing little bit of tweaking, and we'll try to create the object detection architecture. Okay, but before that, this is the paper. Now I know that for the first time it would be very hard for you to go through the paper, and you will get confused like what to read and how to understand the entire paper, because they have written so many things, and this is the complete, I think, I mean, research writing, right? But as as a beginner, this is I mean, very difficult for me to read the paper. Okay, but I'm going to take a session, guys. I'll explain how you can read a paper. Okay, so whenever you are reading a paper, there is a step you have to follow. Okay, there are some technique you have to follow. So if you follow the technique, you can efficiently read any kinds of research paper. Okay, I'm going to tell you how to read the paper. On top of that, maybe I can take a dedicated session, or I can create a YouTube video on top of that. You can refer it. Okay, so see, I always like to read the paper, because whenever I read the paper, it gives more clarity. It gives more, let's say, understanding on top of any kinds of research. Okay, first of all, I do research over the internet. I see different blogs. I see different videos. Okay, then after that, I go through the paper always. Okay, so I open a paper. I try to read. At least you should read the paper at least 1 to 2 times. Okay, 1 to 2 times you should read, like the way you read any kinds of, let's say, newspaper, any kinds of, let's say, books, you can also make a habit to read a research paper, because whenever you are reading the research paper, I can guarantee you most of the understanding would be clear, and you will be getting like more intuitive information from the research paper. Okay, the things you are not going to find in the blog or any kinds of YouTube videos. Okay, thus more information you can get from the research paper itself. That's why I always suggest to my students, or let's say to my followers, try to read the research paper as much as you can. Okay, so this is the research papers. Initially, don't read the research paper. First of all, try to see my lecture. Okay, see my presentation I prepared, because on top of this research paper only I prepared the entire presentation. Okay, so try to see how the RCNN works, then go to the research paper and try to read it. Okay, then your understanding will be more clear, guys. Okay, so this is the paper, and I think how many pages are there? 21 pages are there. It's a very huge research paper, you can see. Okay, on top of the object detection, this was the first research paper they created. Okay, now I will open up my presentation. Okay, so first of all, we'll try to see the RCNN, that means region based convolutional neural networks. So RCNN is nothing but it's an algorithm. Okay, it's a model. Okay, it's a model they have created for the object detection task. Now, as of now, what is our goal in object detection, guys? Tell me, what is our goal? Our goal is to, let's say, whenever I'm having an image, okay, I'm having an image, and inside an image I'm having an object. Let's say in this image I'm having a car. Now let's say as of now this is my object detection model, and it is completely black box. So what will happen if I pass this image in my model? My model will try to classify this is a car, and even it will also try to locate what is the car. That means it will create this bounding box, and this is called object detection. That means here we are not only classifying the object, we are also trying to find out the actual location of the object. We are detecting the object with the help of this bounding box. Okay, that's why we call it as a object detection, and this is the initial goal. Whenever we are creating any object detection model, this is the initial goal. Let's say if I give any kinds of image, my model should figure out the object present in the image, and it will locate that with the help of this bounding box. Got it? Now, what is this bounding box? Bounding box is nothing but it's a square shape. You can see it's a square shape, and we know that how to draw a bounding box. For this, we have to figure out the x and y coordinate. Okay, so I think you know that in image actually, where our coordinate will start, on top. Okay, so from here our coordinate point will start. That means this side you have the x and this side you have the y. Okay, so whenever you will get the x and y, now you have to figure out the w and h, that means width and height of the bounding box. So let's say you have the width and height. Let's say width is 20 and height is also 20. Okay, so what you can do, in the x direction you can go 20, that means width, and the y direction you can go 20, that means this is the height. Okay, now if you complete the drawing, you will be getting a bounding box like that. Okay, this is called bounding box. And how to annotate the data for the object detection? In my previous session I told you we also draw these kinds of bounding box. Yes or no, guys? Tell me. I think you remember RoboFlow platform, guys. RoboFlow data annotation platform, remember? So how many of you have joined that session, guys? Let me know in the chat. How many of you have joined that session, my previous session, introduction to object detection? Have you seen the data annotation part? There I was doing this kinds of bounding box annotation. Let me know. Please reply, guys, in the chat. Have you seen, guys, the data annotation part? Yeah, I think you have already seen that, right? Yeah. So we have drawn these kinds of bounding box there on top of the object I want to detect. Okay, there I was using sign language data, right? Yeah. So that's why initially I showed you the data annotation part. Otherwise, you will ask like, sir, what is a bounding box? Okay, so that's why I took that session. I showed you the entire data annotation part. Now I think your understanding is fine, right? Great. Now, what we do usually, okay, what we do usually in the object detection, let's try to understand. But before that, let's say we have to understand the classification. And how to do the classification? Let's say you are having an image, input image. First of all, you make it as square shapes. Okay, let's say this is the shape of the image and this is the color image. That's why channel is 3. And you use some convolutional layer. Okay, convolutional and pooling layer. Okay, and I think you already know what is the work of convolutional pooling layer. With the help of that, you will do the feature extraction. Okay, so let's say this is the feature map you got after applying the convolution and pooling layer. Okay, and after getting the feature map, you do the flattening operation. Okay, flatten operation. Okay, and after flattening operation, you use something called fully connected neural networks. Okay, so assume that this is the fully connected neural networks we're using, and inside that, let's say we are having that many of neurons. Okay, and what is the works of the fully connected neural network? It will classify, this is the given image and what kinds of image it is. Okay, let's say in this image what kinds of object is present. So here you can see this is the car score. Let's say here we are using softmax activation function. Okay, so it will give you the probability score. So let's say car is having 90% probability, bike is having 0.01 point probability, and motorcycle is having 0.03 probability. That means I can see this is the car. Okay, this particular image has been classified with respect to the car. Okay, and how? Because this is supervised learning. Okay, this is a supervised learning. We use the correct label also. I think in image classification I showed you, we make a folder. Okay, we make a folder, and this is called our actual label. Okay, actual label. So we have the actual label and we have the predicted results. Based on that, we calculate the loss. Okay, and in the backpropagation, CNN backpropagation, we try to optimize the loss. Okay, so whenever loss is close to 0, that time your model will able to classify correctly whether it's a car, whether it's a bike, or it's a motorcycle. Okay, so this is the understanding of the image classification. Got it? So this is the entire understanding of the image classification. Now, how I can tweak this architecture to make it figure out the object locations. Okay, that means how it will draw the bounding box. So for this, we can add another branch in this architecture. See, this is the branch we have added here, guys. Okay, you can see. So see, this is the same branch as you saw in the image classification. Only we have added this particular branch. And what is this branch is doing after doing the flattening operation? That means after the flattening operation, we are using some fully connected networks. Okay, so these networks we are using for the object classification. Okay, whether it's a car, bikes, and motorcycle. And these fully connected neural networks we are using for the box classification, box coordinate classification. Okay, so here we use something called regression. Okay, regression architecture. And here we use something called classification architecture. Okay, so regression architecture, it will give you some points. Okay, it will give you some points, coordinate points. Okay, what is the coordinate points? X, Y, W, and height. Okay, so this bounding box coordinate point, X, Y, W, and height. So these 4 points, guys, it will try to return. Okay, initially. And how to adjust this point, guys? Again, what we have to do? We have the correct bounding box, yes or no? And what is the correct bounding box? The actual annotation, yes or no? I think because of my image, it's not visible. So what I can do, just a minute. I can, now I think this part is visible, guys. Correct boxes just behind my image. Right? So this is the correct bounding box. Correct bounding box, I think, remember whenever we did the data annotation, okay, so we used to create a txt file, and the txt file, our correct let's say image location would be saved. That coordinate points, you remember, guys, coordinate points with the label. This is your annotation file, and in the annotation file your actual label will be present. Okay, actual bounding box, actual let's say box position would be present. Now what you have to do, you have to compare the predicted bounding box and the actual bounding box. Okay, you have to predict the actual bounding box and the predicted compare actual bounding box and predicted bounding box, and with respect to that you will be calculating the loss. Okay, and here we use something called L2 loss. Okay, so that means the loss we are getting from the classification and the loss we are getting from the bounding box coordinates, we have to do the weighted sum. Okay, and this will become your main loss, okay, for the object detection model. Okay, yeah, so this is the little bit of tweak we have done to find the actual position of the image. Okay, yeah, just a minute, guys, give me 1 minute. Fine. All right, now that's how we can identify the actual, okay, actual location of the object. Okay, now see, what is the disadvantage using this architecture? The disadvantage is only one object can be detected. Okay, So if you have only one object present inside an image, then this architecture will work. Okay, this architecture will work. And we call it as a classification plus localization. Okay, I think you remember I told you there is another task called object localization. Okay, but we don't use localization nowadays because this can be solved without the classification. We only do the classification whenever we have the single object inside the image. But whenever we have the multiple object inside the image, that time we can't use the classification. For this we have to use the object detection. Okay, it should detect the all the object present in the image. Okay, yeah. So this is called object localization, guys. Okay, whenever you are using this architecture, that means it can only work with the single object, and we call it as a object localization. First of all, we'll classify, then we'll localize. See, we're classifying, then we're localizing the object. Okay, and this architecture used for object localization, you can see. Got it? So this is the main disadvantage to use this architecture. Okay, now what about for the multiple object? Okay, what about for the multiple object? And from here your RCNN comes into picture. Okay, so whenever you are having multiple object present inside an image, from here your this RCNN comes into picture. Now let's try to understand how RCNN will work. See, what is the old approach, guys? Whenever they propose the RCNN, they used to use something called sliding window. Okay, sliding window. So let me open up my pen, so I think I can explain better. Just a minute. I'll take a color. Yeah. So see, guys, let's say this is the entire image. Okay, you can see this is the entire image you are having, and inside that you are having multiple object. Okay, and what is the old approach? We call it as a sliding window. And how sliding window work? I think you know the stride, guys. Yes or no? In image classification, how stride works? Let's say this is the initial condition. This is the initial condition. This is the initial bounding box. Okay, first of all, it will capture this particular part of the image. Okay, let's say this is the part we have captured. This part we have captured. Now we'll try to use the classifier model. Okay, we'll try to use the classifier model to classify this particular object. Now what my classifier model will do, it will classify how? It will use C plus 1, okay, outputs. What is C here? C is nothing but your actual level. Let's say inside that our actual level is nothing but our car, motorcycle, bikes, and so on. Okay, and what is 1? 1 is nothing but the background. Okay, that means whenever you are getting the background, see, this is the background na. So that time, that means this 1 would be active. Okay, this 1 would be active, and this C would be 0. This C would be 0. That means there is nothing object present inside this particular C. Okay, and this is like a 0. That means 0 plus 1, it would be 1. And whenever it is 1, your model will understand this is a background. There is no object present inside the image. Got it? Then again what will happen? This sliding window come here. It will come here. Again it will capture this particular part. Again it will classify. Okay, then again it will check whether it's a background or it's a class. Okay, so that's how it will do multiple time, guys. That's how it will do multiple time. And there will be a position, this like sliding window will come here. Okay, now you can see this particular object is getting detected here. Okay, now you can see in this box this object is present. That time what will happen? This C would be active. That means inside a car is present. Okay, and 1 would be not active. That means now there is a object present inside the image. Okay, that's how it will try to classify. Okay, now let me move to the next slide. I think your understanding would be clear. So let me clear the board. Yeah, now see this object, see this image, guys. Okay, see, we are using a sliding technique, and now let's say there is a position, your sliding window will come here. Okay, sliding window will come here. Now you can see there is a hill. Okay, there is a hill present inside this particular box. Now it will pass to the classifier model, and it will try to predict as a mountain. Okay, so let's consider as a mountain. Okay, this would be mountain because now there is no background present inside the image. Got it? Now if I again move, now see, there would be a position, yes, sliding window will come here. Now there is a car is present. Okay, now it will predict it as car. Let me know, guys, are you getting? Yes or no? Are you getting? Let me know. If it is clear so far, please write clear in the chat. Please write clear in the chat, guys, if you're clear. Yeah, great. Okay, Now see, there is a problem. Okay, there is a problem. What is the problem? You can maybe observe here. See, whenever we started this sliding window, that time our bounding box shape was like that. Okay, this was the shape. Then when it moved, you can see this is another shape. That means this shape is changing, guys. This shape is changing. Okay, now you can see there is another shape. That means sliding window means you are using a bounding box and you are sliding just right shift. Okay, the way you do the stride operation in CNN. Okay, this is called sliding window. You use a bounding box and you do the slide operation right side. Okay, because you have to move to the every image to find the object present in the image. Okay, this is called sliding window. Okay, now you can see this shape is changing, guys. Okay, initially this is the shape, now this is another shape. Okay, now how these different kinds of shape is coming? Okay, so for this they propose something called it uses external algorithm to propose some regions. Okay, some regions. Okay, some regions, because see, what is RCNN meaning? RCNN is region based convolutional neural network. Region based. What is region? This is the region. So this box you can see now, this is the different region. Okay, and it use something called selective search. It use something called selective search to propose different regions with different shapes. Okay, you can see this is another shapes, this is another shape, this is another shapes, this is another shapes. That means it will try to propose multiple shapes. Okay, multiple shapes inside the same image window. And how many regions it will try to propose? It will give us like a 2000 regions proposal within 1 or 2 seconds. Okay, within 1 or 2 seconds it will try to propose 2000 regions on top of the image with a different shapes. Got it? Because this is the initial assumption. Okay, this is the initial assumption. They are assuming that, let's say, some of the object will be detected in this shape, some of the object will be detected in this shape, some of the object will be detecting in these shapes. Okay, they're doing different assumption. Okay, this is the selective search algorithm. Okay, this is the random initialization they will do on top of the entire image, and this box will try to move. That means it will try to do the sliding window operations every time to find the object present in the image. Okay, yeah, fine. Yeah, now see what will happen in the RCNN. That means we saw like it will use something called selective search to propose the region. Okay, region on top of the image with the different shapes. Now let's say this is the image, input image we're using, and we propose some regions. Okay, let's say as of now we propose 2 regions just to identify, just to understand the concept. So 2 regions you can see, one regions trying to detect the human, another regions will try to detect the horse. Okay, now this is called region proposals, and once it captures the region, you can see this is the person inside this particular box, this is the person, and this is the horse. So it will extract the image from the entire image and it will do the square shape operation. So this time there are multiple boxes doing sliding window. Yes, no coder, you are right. Okay, now see, after getting the proposal, that means once it got some object, okay, present inside that, it will bring here and it will make it as a square shape. Okay, it will make it as a square shape. Now what is the problem with this square shape, guys? Can you tell me? See, before understanding the problem, first of all, what will happen? This particular object, it will pass to the CNN model, okay, convolutional model, and your model will try to classify whether it's a person, whether it's a horse. Okay, it will try to classify. Now what is the problem with this particular proposal, guys? Can anybody tell me what is the problem? If you see the original image and if you see the region proposal output, what is the problem? Let me know. The problem is that, see, this is the entire person. Now you can see this hand has cut off. This hand is not showing in this object. Yes, after getting the region proposal output, this hand is not showing. That means it has only identified this particular part. Okay, because this is the shape. Okay, this is the shape. This is the shape of the region proposal. And for the horse, this ear is not visible. Okay, this ear is not visible. This ear is also cut. Okay, because why? Because this is the shape of the region proposal. Okay, yeah, now how to adjust this box size? Okay, how to adjust this box size? Because we are able to get the object, it is fine, but object is getting cut off. We are not getting the entire object visible inside the image. Okay, this is the problem. So for this we have to fix this box size. Okay, so let's say we have classified there is an object present. Okay, now we are sure that in this particular region proposal there are some object present. Now we have to adjust the box to get the full object of the image. Okay, how to do it? We use this particular technique, guys. Okay, so let's say initially reason proposal propose this px, py, ph, pw. Okay, and there is a concept called bounding box transformation. We have to do some transformation to get this actual, okay, actual box position, actual box size. Let's say this is the initial box size proposed by my reason proposal, and after doing the transformation, this is the output we're getting. Now you can see this box is more good. Now the entire object is present inside the image, but initially it was not possible. Okay, initially this person hand was getting cut off. Okay, but now we can see this hand is also getting detected because we have adjusted the box size. Now how to adjust the box size? There is a formula we use. So this is the formula, guys. We use translation formula and log space scale transformation formula. So here to get the bx, okay, we calculate px plus pw. So px plus pw multiply by tw, okay. So this will give you the bx. How to know how much to transform the image? With this particular equation, okay, no coded. So this equation we'll try to figure out, because you know the back propagation, na? In the back propagation it would be adjusted. Yeah. Then how to figure out the by? This is the formula, py plus ph divided by th. Okay, now whenever this pw and tw is negative, that means your box will move to the negative, okay, negative side, and whenever it is positive, your box will move to the positive size. Okay, so that's how we can get the box position. Now how to adjust the box height and width? For this is the formula, bw, this is the width. And how to calculate bw? Pw exponential of tw. Okay, you will be getting the bw. Okay, this is the horizontal scale. And what is the vertical scale? bh is equal to ph exponential of th. Okay, this will be giving you the height, that means bh. Okay, so that's how you just try to adjust the box position and the box size to get the full visible of the object. Clear? So I think this equation is not visible. Let me again move my image. Now I think it is visible, guys. You can see the BH equation. Okay, this is the BH equation. BH is equal to PH exponential of TH. This is called vertical scale. Okay, that means initially whenever we did the reason proposal, okay, we are getting this kinds of visibility of the object. Okay, now we have to adjust the box position to get the full visible of the object. Okay, and how to do the box adjustment? We do the transformation. And what is the transformation formula? This is the transformation formula. Okay, and that's how we identify our actual box position and the box size. Now this image is much visible, you can see. This is good. Clear, guys? Let me know. Are you clear? Yes or no? I hope you're clear, guys. Yeah, great. So please hit the like, guys. If you're liking the session, hit the like, all of you. Yeah. Now see, here we got to know how to adjust the box position and box size. Okay, but let's say if we get multiple detection, okay, let's say the same object but we got multiple detection. One box is detecting the face of the person, another box is detecting the entire person. Okay, now which one is like more correct? See, guys, which one is the correct bounding box here? The first one or the second one? What if we output two boxes both pointing to the same object, guys? What is the correct one here? As per your understanding, what is the correct one? Let's say the small one is the first and the big one is the second. What is the let's say right one? Tell me. As per our understanding as a human, which one you will consider? Which box? Big one. Yes or yes, right? Big one. But how my model will understand big one? I mean, this big box is the correct one. Okay. For this, it will use something called non-maximum suppression. There is a concept called non-maximum suppression in object detection. Okay. Now, how this non-maximum suppression will work? Let's try to understand. Let's say whenever you have multiple detection in the same objects, okay, it will apply this non-maximum suppression. Okay, now see, this is the ground truth. I think you know all the object will have their ground truth because we have already annotated the data. Yes or no? We have already done the annotation of the data, and our data is having the ground truth value. Let's say this is the original annotation we have done, and the red one is the predicted one. That means the detected one. My model got detected. This is my model detected, and this one is also my model detected. Okay, and this is the ground truth. Okay, now as per your understanding, guys, okay, how I will consider the big one, because I can see this big one is close to my ground truth. This big one is close to this bounding box. It is close to my ground truth. That's why I'll consider this big one would be the correct one, not the small one. Okay, but what about the model? How my model will understand the big one output would be the best fit for my detection. Okay, for this it will be using something called I'll tell you. See which one to choose. Intuitively, the one is that closer to the ground truth. You can see this big one is closer to the ground truth. That's why we'll be considering this one. But what about the model? Okay, my model will try to understand this thing with the help of intersection over union. That means IOU. Maybe you have heard of this name, guys. Okay, in object detection, yes or no? IOU, intersection over union. Okay, and how to calculate the intersection union, I think you already learned in your college days. In Python also we usually teach that. Okay, intersection, then union. Okay, so let's say this is my box. Okay, this is my box. So this is my predicted box, detected box. Now I'll try to calculate the intersection over union with respect to my ground truth. Okay, so let's say this green one is my ground truth, and this red one is my predicted one. This two red one is my predicted one. Okay, now if I calculate the intersection first of all, guys. Okay, what is the intersection? Intersection means this particular part. This part is called intersection. See, this particular common part is called intersection. Okay, now see, this is the intersection. This is called intersection. And after calculating the intersection, let's say we got 12. Okay, 12 is my intersection. Okay, then we'll be moving to the union. And how to calculate the union? This part is called union. Okay, this part, the inter part is called union. And let's say we got union is equal to 25. This is just an assumption number as of now. Just try to consider. So maybe it's not visible. So what I can do, I can move my image here. Now I think it is visible, guys. You can see this is the intersection and this is the union calculation we are doing. First of all, you will try to see the intersection. So as of now, we are considering this box, guys. Okay, the first detection box. That means this one. Let's say the big one. Okay, we are considering the big one. Okay, this big one, and on top of the big one, we're calculating the intersection over union, and this is the result we got. This is the intersection result. This is the union results. Okay, that means 12 and 25. Okay, 12 and 25. See, this is the result we got, guys. Okay, now similar wise, we also need to do it for the small one. And now let's say we have done for the small one also, and we got 3 divided by 20. Okay, now if you see the small one and the big one, so if you just calculate the number, which will have the more value, guys? Definitely 12 divided by 25 instead of 3 divided by 20. Okay, so this will having the more number, that means 0.48, and here you are getting 0.15. Okay, now as per your understanding, guys, which one I have to select, the big one or small one? Tell me, because here I'm getting the more value. Okay, here I'm getting the more value. That means my big one would be selected. This big box would be selected. Okay, that means this big box. This big box would be selected because it is having the more value instead of this one. Okay, so my model will understand in that way. Okay, it will calculate the intersection over union, and whichever will be having more value, it will be selecting that particular box, and rest of the box it will try to remove. Now let's say this small box would be removed, and this is my correct box right now. Clear, guys? Tell me, what is intersection over union and how it is working to identify the best fit box? Tell me. Clear? Let me know, guys. Are you clear? Yeah. Okay. But see, there is a note. We use non-maximum suppression when the object is the same for all the bounding box. Okay, so whenever your object is same, let's say in this scenario, my object are same, all the detection, it is detecting the same object. Okay, that's why we can apply this non-maximum suppression. But whenever you are having multiple detection on top of multiple object, that time you can't use the non-maximum suppression because now you are having different object. Okay, So this is one example. Let's say this box has detected the person and this box has detected the horse. Okay, now objects are different. That time we can't use the non-maximum suppression. Only we can use whenever we are having the same object present inside the image. Okay, yeah. So here I have written we use non-maximum suppression when the object is the same for all the bounding boxes. Okay, not the different one. So let's say that's how your entire detection works, guys. Okay, that's how entire object detection method works. Okay, now how we can evaluate the model. Okay, let's say we have done the object detection model training. We know that like model is fine. Okay, we have trained the model, but how to evaluate the model? Let's say in image classification we used to use classification metrics, right? I think you know the classification metrics wise we used to use accuracy score and losses, right? But what about the object detection evaluation? Okay, for object detection evaluation we use a matrix called mean average precision MAP. Okay, we use something called mean average precision MAP. Okay, MAP score we have to calculate here. Now how to calculate mean average precision? Let's try to understand this part. So for this, let's say I'll be using this particular image. So here green one is the original ground truth. Okay, so this green detection is the original ground truth and the yellow one is the predicted ground truth. Predicted detection. Okay, here you can see this green one is the original ground truth. That means we have labeled this image, and the yellow one is the detection from my model. Okay, now which predicted bounding boxes are correct, guys? Here, tell me. So let's say my model predicted three detection. So number 1, number 2, number 3. So here which one is the correct one? Number 1, 2 or 3, guys? Tell me. So let's say if my intersection over union, let's say the threshold value we have considered 0.5. Okay, 0.5. So I think you are getting the value now here. I think remember. So this value you are getting. Okay, so let's say if we are considering as of now our threshold value is 0.5. That means if it is more than 0.5, okay, if intersection over union is more than 0.5, that time I can consider this is the correct detection. And if it's less than 0.5, I can consider it's a wrong detection. Okay, now you can see 2, 1, 2 and 3. So 2 is getting more intersection over union. Okay, that means it is more than 0.5. You can see this number 2 is getting detected. It is closely to the ground level. That means your actual level. That's why I can consider number 2 detection is correct and 1 and 3 is not correct. It's wrong. Okay, now here you have to calculate the precision and recall. First of all, you have to calculate the precision recall. Okay, how to calculate the precision and recall? Precision means on top of your entire detection. Okay, on top of your entire detection, how many of them are correct? So here how many of you are detected, guys? Entire detection, like how many entire detection you are having? 3 detection, yes or no? 1, 2 and 3. Okay, so in the 3 detection, how many of them are correct? Only 1, which is nothing but 2. That's why 1 divided by 3. This is called precision. Okay, and what is the recall? Let's say based on your actual level, that means actual annotation, how many of them are correct? Okay, let's say how many annotation we have guys. How many ground truth we have? We have 2 ground truth. Let's say this one and this one, this green one. And how many of them are correct? That means correctly classified, correctly detected? Only 1. Okay, which is nothing but 2. That's why 1 divided by 2. Okay, so this is called precision and recall. And how to calculate? I already told you. Precision means how many detection you have applied, and on a bit in that how many of them are correct. Okay, and what is recall? Recall means how many ground truth you are having, and based on that how many detection are correct. Okay, so we have to calculate the number. So let's say to understand the mean average precision, first of all we have to see this image. Okay, what is mean, guys? Mean means you should have multiple object. Okay, you should have multiple object, multiple class. Okay, so let's say as of now we have given the example with the help of dog. Now let's say we are also having the cat. Okay, so first of all we'll try to calculate the average precision with respect to the dog. Then we'll try to calculate the average precision with respect to the cat. Then we'll try to mean them. Okay, we'll try to get the mean. Okay, mean average. Then it will become mean average precision. Okay, let's try to understand. Let's say this is the dog image. First of all, let's try to calculate for the dog image. So let's say this is the original detection and this is the predicted detection I got. Okay, so you can see this is the original and this is the predicted one. Now whenever you see the intersection over union and you calculate the precision and recall, you will be getting the number. You can take a pen and paper, guys. Whatever thing I showed you now, how to calculate precision recall, how to calculate IOU, that means intersection over union. If you calculate, you will be getting the number. Okay, so let's say first of all consider this particular box, the first box. Now can you tell me, guys, this first box is right or wrong? You can see that this is the confidence level 0.9, that means 90% confidence here this particular object is present. Now tell me, guys, this particular detection is wrong or correct? The first one, wrong or right? Tell me. So this detection is wrong or right? If you calculate the intersection over union, if you keep the threshold value 0.5, you will see that it is right. Okay, this is the right one, so we can consider this is the right one. And if you calculate precision and recall, this is the number. Okay, and this number you have to plot in this particular precision and recall curve. Okay, precision, this is called precision and recall curve, guys. Okay, so here you have to plot. So here we got 0.33, so 0.33 would be plotted here. Okay, now I'll move to the next detection. Okay, this is the next detection. Now tell me, this detection is right or wrong? This detection is right or wrong? This one, definitely this is wrong. Okay, because here this object is not getting detected. If you calculate the IOU score, it would be very less. Okay, so that's why it's wrong. And again, if you calculate precision and recall, you will be getting this number. You have to plot in the precision and recall curve. Okay, that means this 0.33 again will come here. Okay, now we have to calculate for the next box. Okay, what is the next box? Let's say this is the next box. Okay, now as per the box, you can see this object is getting somehow detected. Okay, somehow detected. Now if you calculate the intersection over union, it would be more than 0.5. Okay, so now I can consider this is also correct, and this is the precision and recall. You have to also plot here. Let's say 0.6 is here, you have to plot it. Okay, now what about the last one? This is one. So this one is not correct because you can see there is no object present, so I can consider this is a wrong one. And this is the precision and this is the recall. Okay, that thing you have to plot here. Now you have to draw all the dot here. See, you have to draw all the dot, and in this curve you can see you have to get the average precision. That means you have to calculate the average of all the number, and this is called average precision, guys. Okay, this is called average precision. Okay, before calculating the mean average precision, you have to calculate the average precision. I think my screen is visible. Let me show you. I can move to my image here. See, this is the image, guys. This is called average precision, and this is the precision and recall curve. Okay, so you have to calculate for all the detection and you have to plot in the curve. Okay, based on the precision and recall, and you will be getting AP score, that means average precision score. Okay, now this is for the dog. Let's say AP score for the dog we get 0.58. Then we have to do for all the cat image. Okay, then let's say AP score we got 0.62. Now if you combine, if you do the mean average, okay, if you do the mean, so you'll be getting MAP, and MAP is nothing but 0.660. Okay, so this is called mean average precision. Okay, whenever you are having single classes, that time you will be calculating the AP score, average precision. And whenever you are having multiple classes, that time you will be calculating the mean average precision. You have to calculate the mean that time. Okay, and this is the final number. If this number is close to 1, that means your model will get highest accuracy. Okay, if this number is close to 0, that means your model is performing very poor, let's say, performance. That means your model is not good. This number, highest number would be 1, okay, and lowest number would be 0. In between, you have to adjust the number, and it would be adjusted during training, guys. Okay. Yeah. Now see, the mean average precision we have calculated, it is based on the 0.5. 0.5, why? Because the threshold was 0.5. The IOU threshold was 0.5. Okay, see, this IOU threshold you can also adjust. See, this is the IOU score. Now we have calculated based on 0.5. Now you have to increase slightly. That means after 0.5 you will be adjusting to the 0.55, then 0.60, 0.75, 0.95. That's how you have to also adjust. Okay, and if you calculate all the MAP score, and if you take the sum of them, okay, so this will become your actual MAP score, and this is the final result, guys. We call it as a MAP score, that is mean average precision. Okay, now I'm going to show you the training, guys. In the training, you will be getting these kinds of metrics. That time, don't ask me the questions, sir, what is MAP score, what is 0.5, what is 0.55, what is 0.60. Now I have clarified each and everything. Okay, so whenever I'll show you the training, guys, you will be getting these are the number, and this is your evaluation metrics for the object detection. Clear? Yeah. So this is the entire understanding on top of the RCNN, guys. Okay, that's how your RCNN works. That's how object detection works. But what is the issue with the RCNN, guys? The issue with the RCNN is it is using sliding window technique. And this sliding window technique takes lots of time, because it has to slide all over the image, one by one, all over the image. And how many reason proposal it is using? 2000 reason proposal it is using. Now just try to see the computational power and try to see the time, guys. Okay, because of that it is like very slow. Okay, this particular RCNN is like very slow. Here I can write why RCNN got deprecated, because it was like very slow and computational expensive. Okay, that's why researcher proposed another architecture called fast RCNN. This is the updated version of the RCNN. Now how our fast RCNN will work, I'll try to explain in my next session, guys. Okay, then again there was some issue with the fast RCNN. Then again they proposed something called faster RCNN, and this is the this is like the best architecture we got in the field of RCNN. Okay, RCNN architecture. And this architecture everyone use, guys, nowadays. Okay, all the framework you will see like Detect-on-True or any other framework like TensorFlow, this architecture they are having, this model they are having in their models. Okay, not the RCNN and fast RCNN model, because this is like very slow and computationally expensive. Okay, so guys, now tell me, did you understand the entire concept of RCNN? Let me know. If you understand the RCNN, you will be understanding the fast RCNN very easily. Okay, so here they have done some tweaking and they created another architecture called fast RCNN. We'll try to export in my next session. Let me know if clear. Please write clear in the chat. If not, please write not clear in the chat. Not coder telling who are these genius people inventing new things, and we are just here and learn them are the real heroes. Yes, definitely. And this is the researcher, guys, I told you. So these are the researcher proposed, these are the architecture. And this is the organization name, US Berkeley. Okay, US Berkeley. What is US Berkeley? I think it is university. Yeah, it's a University of California, Berkeley. Okay, so they were the I think teachers, okay, in the university. Now you can go through the entire research paper, guys. Okay, just try to read whatever things I explained, okay, through my entire slide. The same thing they have explained in the research paper, but in a theoretical term, okay, in the research term. And no need to worry, I'll take another session there. I'll show you how we can read the research paper effectively. Okay, yeah. So fine, guys, this is the idea of our RCNN. Now next session, let's try to catch up with our first RCNN explanation, and definitely we'll be able to understand. After first RCNN, we'll try to understand the faster RCNN, and we'll go to the practical implementation of it. Okay, and if you haven't subscribed to my channel, guys, please try to subscribe if you like my content. Please try to support my channel. Let's hit 50k subscriber as soon as possible, and definitely this is my promise, you will be learning a lot, okay, from this channel itself. So how was the session, guys? How was the session? Did you like the session? Most of the people has the confusion on the RCNN, fast RCNN and faster RCNN architecture. Okay, they don't know how the things works. Okay, now I think I'm able to clarify. So that's why I took, guys, some times to prepare all of the materials because I want to show you, okay, the clear explanation. Now I think you can visualize everything in your mind, okay, how things are working. In computer vision, you have to visualize at the end, okay, nothing else. Yeah. And whenever my next live will come, guys, you can check out my group, my Telegram group. So there I will try to update, and you can check the live section always. Keshav, maybe 30 to 40 session I need. Okay, Keshav. Let's see. Yeah. Plus minus 30 to 40 session. Okay. Yeah. Okay, guys. So we are done with our discussion. Please try to like and please try to read the paper, because the more you will be exploring, the more you will be reading. Okay. So your understanding would be more clear, guys. Thank you. Bye, everyone. Good night. Take care. Bye, everyone, guys. Thank you.